Chris, how you doing, buddy? You can turn your mic on, bud.
What did you say? I'm sorry, it was connecting to the audio.
Oh, as I said, good morning. How you doing?
Oh, I'm doing good. I'm tired.
Well, that's okay. Getting towards the end of the week.
Yeah.
Has homework been kind of heavy for you this week?
Yeah. Plus, I work every day, so it's
Ooh,
on top of that.
you might have told me before, but tell me again. Where do you work?
Subway.
Oh, nice.
Yeah.
All right. How is it working there? I've never had that job before when I was younger.
It's not too bad. I work at the one that's like less busy, so it's pretty laid back.
Where is that?
It's over by Best Buy on Butterfield.
Oh yeah, yeah, I know where that is. I live in Wildemar, but
Uh,
obviously I go over there because I work over there with typically, at Great Oak. Good morning, Alyssa, Natalie, Talia. How you guys doing? Oh, I have more people too. I have Caitlin, Garrett. How we doing? Good morning, guys. Give me some smiles out there, even though it's early. There we go. Thank you, Preston and Natalie. There you go. All right, it's good to see you guys. Get prepared. Okay, you'll see. I sent out a message, but also have you're gonna need graph paper here today. Obviously, a calculator probably, because stats there's usually a lot of calculator work. So have that side by side with your computer and get ready to rock and roll with me. We're gonna do some examples here together. Preston, you're cracking me up here. You're getting me dizzy too. You're Jesus. Okay, guys, get ready. Look at the screen here. You're gonna need notes, calculator, and everything, and we're gonna be working together here. Obviously, it's good to see everybody. I see Logan, Rebecca. I see Kayla's over there, and I don't see everybody else, but I wish I could see Grant, Angela, and Audrey. You guys, let me see your faces so I can get to know you guys. It is, when we go back, hopefully we get to go back, in a few months, to school. And I would like to put a face to the name because you guys are people. So I appreciate you guys turning on your videos. And if you don't, okay, I understand. Just make sure you're following along because that's important. Preston, get settled there, Tiger. You're getting me dizzy. Okay. Okay, we need the start immediately here, so get ready, please. We're going to get right into it. When we do stats or do a lot of mathematics here, it takes quite a bit, especially when I put you guys in breakout rooms back and forth like we did last time. So we're going to do something similar last time. It's going to be obviously mathematical because this is in my opinion, the toughest lesson or the toughest section in chapter 1. And so we need to spend a few days on it. One day last week is not enough when we went over z-tables and probabilities. That's just the tip of the iceberg, actually. So I need to spend more time with you, give you a chance to see some more examples, different examples, give you a chance to work with your classmates in breakout rooms and then, some practice. I mean, that's how you get good. Watching a video initially that was produced by Mr. Alex is for our classes here is not enough. That's just totally not enough. You got to get a lot of experience mathematically. So everybody look at my screen here. You need a calculator, you need graph paper. That would always be wise. And we'll get started here in about 1 or 2 minutes. Let's start off with any questions or concerns or needs like I always do here. Sometimes I do high and low. Sometimes I do questions, concerns, needs. Do you need tell me, how can I help you guys out? If you have anything that you need to request from me or any way I can help you out, make sure you let me know. I will do whatever it takes to help you guys be successful in your senior year in high school. Big last year. Okay. I don't see any questions. Okay. Then let's get right into it here. I'm going to do something similar as last time. I'm going to lead off with an example. And then, of course, I will go back and forth between, an example and breaker rooms to give you guys a chance to work with me and work with each other. Okay. Here we go. Let me see. And I'm going to start pretty quickly. Today I'm not waiting too much time because we need the time. So always have your notes graph paper calculator handy in this class so we can get started. And my goal is to hopefully finish with a half an hour or more left in class to allow you guys time to solve one problem. I'm going to give you one homework problem like I did last time. And you're going to be submitting all your notes and your homework problem in Canvas today. It's already set up. If you notice that in Canvas, then that's where you're going to be submitting your work. Okay, so let's get started here. Like I said, let me just type it one more time here. Oh, I got to take it off. So we need some room. You're going to need about 3 or 4 pages of graph paper, just to let you know, just to have plenty of room. Graph paper's a little bit better only because we're going to be drawing the bell curve, and it helps when you have graph paper. So here we go. We're going to be talking about the empirical rule, or what's called the 68, 95, 99.7 rule. All right, which I really didn't get into last time. I touched on it, but I didn't really give a whole lot of examples on. So today we focus on what's called the empirical rule, otherwise known as the 68, 95, 99.7 rule. So what in the world is that? In the video, it was discussed, but let's going to go through it again. So I'm going to discuss it one more time to give you a chance to absorb and ask questions. After you guys feel comfortable with it, we're going to get right into an example, and then I'm going to put you in a breakout room with your classmates. Okay, so here we go. Let's talk about it first. What we're going to do is draw the bell curve. So we can draw the distribution. That's the first thing. So draw, okay, the distribution, the normal distribution, I should say. Okay, because these are normal distributions, keywords. There's different types of distributions in mathematics. This one commonly occurs in nature, so it's discussed quite a bit. You're going to be doing this in your practice. You're going to be doing this in your homework to draw the curve, because it helps you see things. It helps you understand things. In fact, I don't even, it's pretty even difficult for me to solve these problems without it. Okay, so here we go. Let's draw a curve, the normal bell curve. Okay, so draw a symmetrical bell curve. It's symmetrical. It doesn't have to be perfect, but just do your best job here. And then again, as always here, guys, I know taking notes and listening, especially online, is a little bit difficult at times because you can't pause and play because I'm not a video, okay? So if I go too fast, just type in the chat, please slow down. If you have questions, turn on your mic and ask, and, just feel free to talk to me at any time and ask questions at any time, okay? Okay, now the mean on this symmetrical bell curve is always right down the middle. So put that in red. This is the mean. It's called mu. There's your symbol. Okay, and that represents the mean. Whatever that is. It separates the bell curve into 2 symmetrical halves. 50% of the data lies on the right. 50% of the data lies on the left. Okay, and let's draw in the standard deviations, 3 of them. So go 1 standard deviation to the right. Okay, that corresponds to sigma of 1. That's the first standard deviation. Remember, this stands for the sigma, the lowercase sigma stands for standard deviation. I'll just put the symbols at the top, just to make sure that you guys are familiar with them. I remember when I was in math class, especially in college, when math was extremely difficult, especially in master's school, I spent half the time, guys, trying to figure out what all the symbols meant. And then after I figured out what all the symbols meant, then I tried to figure out what the teacher was saying. And so if you're not sure about the symbols, just make sure you say, stop Ainsworth, yo, whoa, 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 slow down, dude, okay? What in the world are the symbols? All right, here's another one at you. It's called mu. It's got a funny symbol here and it represents the mean. Okay, so those are the 2 most important symbols that we're working with now. All right, mu is the mean, and sigma, this is pronounced sigma, okay? It's a lowercase sigma, not the uppercase like that, looks like that capital E that we dealt with previously, okay? Talking about lowercase symbol. In mathematics, we use all the Greek symbols. That's just standard, okay? When you go at 2 deviations to the right, okay? When you're right of the mean, when you're at the second standard deviation, they're all positive. So positive sigmas, or excuse me, why do I say sigma? I said, oh. I'm sorry, I'm getting mixed up here. I'm sorry. So sigma standard deviation, I meant down here Z, your Z score, sorry. All right, Z corresponds to 1, your first standard deviation there, sorry. And then Z equals 2, your Z value. When the Z value is 2, you're at the second standard deviation. I apologize, so fix that there. And then when you're at the third standard deviation there, that corresponds to Z value of 3, representing 3 deviations away from the mean to the right. So positive Z values mean you're to the right of the mean, which just simply means, yes, Mateo, that's true. And then if it's negative, it just means you're less than the mean, to the left. Okay, so let's go left of the mean here. So 1, and this is symmetrical, so go the same distance on the other side. All right, so this corresponds to Z value -1, which means you're just 1 standard deviation to the left. That's all it means. It means you're less than the mean. And then if you go 2 deviations to the left, you're at -2. Okay, and then one more, we'll just go one more here. We're gonna go 3 deviations to the left and you're at -3. So when you're left of the mean, Z values correspond to be negative. If you're right, it corresponds to positive Z values, meaning that you're greater than the mean or to the right of the mean. Okay, so what does the 68, 95, 99.7 rule refer to? How do you, what do all these, what are the percentages inside the bell curve, and so on. So let's go through that in detail, because once again, it was one over in the video, but it's probably been a week since you've seen that. So let's go through it in detail. Okay, so when you're in 1 standard deviation of the mean, so let's go through each step. I'm gonna be very specific so you really understand here. So let's see here. Let me scoop up. So when you're within 1 standard deviation, like in here, if you're in this section of the curve, like in here, and by the way, having some highlighters in this section might be really handy. So if you have 3 or 4 highlighters, you might want to grab those just because it helps you see things better. So if you're between -1 and -2, if you're within 1 standard deviation of the mean, let's write this out. So within 1 standard deviation of the mean, you can abbreviate your notes there so you can keep up with me. Okay, so within 1 standard deviation of the mean, whatever that mean is, okay, there is 68% of the data. Okay, there is 68% of the data in a normal distribution. Okay, and that's in any normal distribution. So if the data is normally distributed, well, no matter what the data set is, whether it's scores of calculus students, whether it's a score in any class, I don't care. If the data is normally distributed, okay, 68% of the data lies within 1 standard deviation of the mean. Okay, which means in this yellow region right here that I'm drawing right here, 68% of the data occurs. So you're going to put half to the right of the mean and half to the left of the mean. So you're going to take 68 divided by 2. Can you guys respond in the chat? Who's with me out there? What's 68 divided by 2? All right, do some simple math with me here. 68 divided by 2. Thank you, Shannon and Alyssa. There you go, and everybody, there you go. So now let's put that in. So 68 divided by 2 is 34. So 34% lies to the right within 1 standard deviation, and 34% lies to the left. Remember, it's symmetrical. So between -1 and 1, those Z values, those standard deviations, all right, 68% of the data lives there, okay? 6% of all the data set lives in there. So 34% to the right, 34% to the left, okay? Now, if you're within 2 deviations, let me do something here. So if you're within 2 deviations, between these values here, between Z equals -2 and Z equals 2, so that, let me switch colors now. So this is what I was saying, having color might help you out a little bit, see things a little bit better here. Okay, so right there. So the rule is 68, then 95, and then 99.7. So within that, okay, within 2 deviations, 95% of the data lives. Okay, so let's write that out. So part B, this is the second part. So within 2 standard deviations, go ahead and abbreviate your notes a little bit. All right, 95% of the data lives. Okay, there is 90% of the data exists. Okay, so we need to figure out, you know, what the percentage is in here in this little blue area right here. What is it in there and what it is in, you know, all in through here. A couple different ways to do it, okay? But we got to figure out that percentage because in an actual application problem, we're going to use these percentages instead of using the z-table, because the empirical rule is used when you don't have the z-table. It's an approximation method. Okay, so what we need to do is take 68 from 95 first. This is one way you can do it. Okay, so 95 minus 68, so let's subtract 95 minus 68%. All right, 95% minus 68%, and then we'll divide it by 2 and put it in the blue regions here. Okay, so help me out a little bit. What's 95 minus 68? Okay, get going with your calculators or do in your head, one of the two. Help me out. What's 95 minus 68? Okay, I agree with that, Alyssa. So it's 27. Now this is symmetrical. So we're going to put half on the blue area on the right and then half on the blue area on the left. So we have to take that and divide it by 2. So what's 27% divided by 2? There you go. So I need you guys to really, again, have your calculators, you know, side by side with your notes. And then again, use that keyboard, put in the chat. If you don't like typing, then just turn on your mic on and off, okay? But again, try to participate here and do the calculation. So you divide that by 2 and it's 13.5%. So in here is 13.5%. Over here, 13.5% because it's symmetrical, okay? One of the keys in this, what I'm doing here is symmetry. Okay, the right half is symmetrical on the left half. And because of that, whatever you know on the right, you also know on the left. Okay, now the third thing is within 3 standard deviations is 99.7%. Okay, that's where the 3 numbers come from. So let's talk about that. So again, it's called the empirical rule, but you might want to remember the 68, 95, 99.7 rule, because if you remember that, the numbers, then doing what I'm doing now is going to be easy when you apply it here in a minute. So part C, so within 3 standard deviations, okay, 99.7% of the data exists. Okay, so what we need to do is figure out these little green areas in here. So from, let's say from, so out through here, 99.7% of the data lives between z equals -3 and z equals 3. Let me make this a little bit bigger for you here. In that region, you switch to green, so all the way through here. Okay, in that green region, 99.7% of the data, which is most of the data, lives in that region. Okay, so there's many different ways we can get these values because we need to figure out the area in green in here on the left and on the right. And it's a small number, all right? There's a couple different ways you can do it. We could just take, well, I give that to you guys. How do you guys want to calculate this? A couple different ways we can do it. Who's got a suggestion here? We got to figure out the area in green here. The total area between z equals 3 and z equals -3 is 99.7. All right. Between z equals -2 and 2 is 95. And we want to figure out the area in green. So get creative now, guys. How can we do that? How can we calculate that? There's like 3 or 4 different ways you can do it. Who's got an idea? %95 lives in here. Look in the red. That's 95% of the data.
Would we just do 99.7 minus 95?
And then how would you get the area just on the left?
Dividing the answer by 2.
Okay, so let's do that. So what's 99.7 minus 95? Come on, guys, help out. That was a great idea. That's one way we can do it. Either speak up or put in the chat, one of the two. Let's calculate together here, guys. 99.7 minus 95. So we got 4.7%. Now we got to put half on the left. So we got to take 4.7% divided by 2. There we go. Thank you, Rebecca and Colson and Alyssa and all you guys. Okay, so you said 2.35%. Okay, that goes in here, 2.35%, 2.35%. Very good. Okay, so the only thing we need to do now is figure out the remaining area, which is, it's not drawn to scale, but we got to figure out these areas here. What's in there? So let me back out here. So, okay, I put my work up there, but that's how you got it. How do you get the area in purple here? So beyond 3 standard deviations, how do we calculate that? Because we got to put a number in there. And the key thing here, so again, let's talk about this area in through here. Remember, the area underneath the curve is 100%. That's another key fact. So key fact number 1 is symmetry. Key fact number 2 is that the total area, let's write this down at the very top, total area or probability under the curve is 100%. Okay, so let's focus in on 1/2 of the curve, meaning to the right of the mean. So everybody focus to the right of the mean. I'm talking about, well, I've got a lot of colors going on here, but to the right of the mean. To the right of the mean is 50%, okay? 50% to the right, 50% to the right, and then of course we have 50% to the left. How can we use that fact? 50% of the curve lies to the right of the mean, 50% of the curve lies to the left of the mean. So what's one thing we could do to find the area in purple? Because we need that number 2 as well. It's a very small number, by the way, because we don't have very much left over. How can we use the number? Go ahead.
You can subtract 99.7 from 100.
And then do what?
Divided by 2.
Okay, that's a good method here. So let's do that. Would you repeat that? Because that was good, Alyssa.
You take 100 and subtract it by, and then 99.7.
Okay.
And then divide it by 2.
Okay, so let's do that, guys. What's 100 minus 99.7? Let's step it out. Step 1, because what she said is one way you can do that, 0.3. Okay, and she said divide that by 2, so 0.3% divided by 2. There we go. Good job, guys. So 0.15%. So in here, this little teeny area, and again, it's not drawn to scale, is a very, very small percentage. It's not even 1%. It's less than 1%. It's like 1/5 of 1%. And over here is the same thing. It's symmetrical, so 0.15%. So these are the approximate percentages, commonly known as the empirical rule, or I remember it, and I suggest you guys remember it as the 68, 95, 99.7% rule. Okay, these are all approximate. So making a little note of that. So key fact number 3. Okay, these percentages are approximate. So approximations. In fact, let's highlight this right here. So some of the key facts. This page right here, I want you to keep on your desk. This is the one that we're going to refer to in all your practice today and in your homework. We're going to use these percentages here. So keep this, grab a new piece of paper, and let's do our examples on another one so that you guys can have your work, your examples, side by side with this. This is the key, all the key numbers that you need when the data is normally distributed, when you're figuring out, certain things based upon what's called the empirical rule, or what I remember as the 68, 95, 99.7 rule. Now, before we get into an actual example, any questions on the formation of the numbers? Because if you forget, anytime, you're going to have to develop this on your own. How are we doing so far? And if there aren't any questions, type in all good. If you're really following me, how are you getting the numbers? Where the numbers are coming from? Any questions? Mathematical. Rebecca's good. How about everybody else? You guys feel comfortable in developing all that? I'm getting a few head nods, a few. Okay. All right. And then those people, you guys, there's many people without their videos on. I hope that you guys are following me here behind your computer screens. Okay. So keep that in mind. So everybody keep this off to the side. This is the done, and grab a new piece of paper. Here we go. We're going to get right into an example. Okay. Example 1. Here we go. Now we get to deal with actual numbers. Okay. Now we get to apply it. So suppose we have test scores in a physics class. So suppose test scores, that's something that you guys can relate to, okay, from a physics class, and it doesn't matter what class it is. So let's say it's from a physics class of 800 students, important number there. So the total people in this class, in the physics classes total is 800 students. All right, is normally distributed. So I have to tell you that. So it's normally distributed. So underline those 2 words. Because data is not always normally distributed. Most of the time it is, but sometimes it's not. And so whenever you're solving stat problems, you have to know what type of distribution it is. And those people that are going to go into college and study stats in more depth, okay, you're going to find out there's other just types of distributions. But let's suppose it's normally distributed with a mean. Okay, with a mean, that's mu, okay, equal to, let's say, 75. Okay, let's highlight that. That's important. So we have a mean of 75 and a standard deviation. Let's say we'll call it lowercase sigma, and let's say that standard deviation is 7. So that's the second number that's super important in here. So now we have real data. We have a total class, total number of students is 800. That's going to be used in some cases. And then we know the mean, and then we also know the standard deviation. So the first thing we do is we draw the distribution of the data. So number 1, okay, we draw the distribution. Okay, that means we draw the bell curve. So let's do that. But this time we're going to put in the actual numbers. So before we just talked about percentages in general. Okay, in any normal distribution, those percentages apply, and we're going to use them in a minute. So I'm going to refer back to the graph that we had initially here in a minute. So go ahead and sketch your symmetrical bell curve. Do the best job you can right there. There we go. Put in the sound effects. Okay. By the way, how is my speed right now in my presentation with you guys? How am I going? Is the speed okay? Is it too fast, too slow, just right? What is it? Give me some feedback here. Because if I'm going too slow, I'll speed it up. Because I don't want to go too slow. Okay, and I don't want to go too fast either. Okay, sounds like I'm doing okay. Good. All right, so help me out a little bit. What goes right in the middle? What is always in the center of the data in a normal distribution? Okay, what goes in there? Okay, Joseph says faster. Okay, oh, no. Here we go. Let's ramp it up here. All right, Braden said the mean. Okay, here we go. So the mean right here is 75. So here we go, 75, that's mu, that's mean. Okay, and now we're going to use the standard deviation. So we're going to add 7 3 times to the right. We're going to subtract 7 3 times to the left. Doesn't matter which one you do first. But use graph paper, make it symmetrical. Okay, so this corresponds to z equals 1, z equals 2, z equals 3. So we're going to add 7 to the right each time. 75 plus 7 is 82, plus 7 is 89, plus 7 is 96. Whoops, gotta write down the right number, 96. Okay, so you add the standard deviation to the right. Positive scores are always to the right, and then negative z-scores are to the left. Now remember, this graph is symmetrical. All right, that's why I asked you guys to take out graph paper, because it's a whole lot easier, all right, to draw a good graph when you're using graph paper. Not that you have to, it's just easier. Okay, so I added 7. Okay, remember, standard deviation is 7, that's sigma. So I add 7 each time to go to the right, and then I subtract 7 to go to the left, okay? Because when you're less than the mean, obviously you gotta subtract. So 75 minus 7 puts you at 68. So let's go to the left now. So we got 68 here, minus 7 is 61, minus 7 is 54. So that's the first thing you do in this type of stat problem, is that you draw the curve, you put your data in, and then you can answer all kinds of questions without the z-table like we did last time. Yes, last time we practiced a lot of problems using the z-table, and I showed you guys how to use the z-table properly, figuring out different probabilities. Today, we're going to be using the empirical rule, okay? So let's put that up here. We're going to use empirical rule. Okay, and if you don't like that word, okay, just write down, I don't know, 68, 95, okay? 95, 99.7 rule. Same thing. Okay. So what you need to do now in order to answer a bunch of questions here, you got to put the percentages in. Okay, so have your previous one, have this graph here that we generated it side by side. Okay, and you're going to take these percentages and put them into the graph, and we're going to answer all kinds of questions. So insert the correct percentages here. So within one standard deviation, right in through here lies 68% of the data. So 34% here, 34% here. Work ahead of me. Okay, and then within 2 standard deviations, we have a different situation. We have 95%. All right. And so we have 13.5% here, 13.5% over on the right, same thing, it's symmetrical. So you want to put the percentages in so you can see things easily, and then you can calculate easily. So today I'm using an approximation method called the empirical rule, or the 68, 95, 99.7 rule. And then once you put your percentages in, you're good to go and you're ready to solve a problem. All right, and let's put the other percentages in here, 2.35%. Over here, 2.35%, and then 0.15%, and again, 0.15%. Not totally drawn to scale, but that's close. Okay, and now we're ready to answer all sorts of questions. Okay. So that's the first thing you got to do. You got to draw the distribution using your mean and your standard deviation, and then answering questions based upon these numbers in the graph is fairly straightforward, I think, okay? I don't know, you'll tell me. You guys, we'll do it together here. So let's go through some basic questions. Just checking to see if you guys are ready here. So first basic question is this. So what is the percentage of students, let's say between 68 and 82. All right, between, keyword between 68 and 72. Okay. So now time to, let's do some class response, and everybody, especially the people without your videos on here, I need you guys to really participate in the chat to make, to let me know that you're actually with me here today. So first basic question, please respond in the chat here. What would that percentage be of students between 68 and 82? Just look at the graph. No calculation needed. All you do is look at the graph. Percentage. Let's underline that word. Between 68, I'm sorry, not 72, sorry. Scratch that. Everybody Uh, I'm at 68 here, okay, and 82. We're not using the Z table. That would have been a Z table question. I meant 82. So I apologize. Let me ask the question again. I went too fast. Between 68 and 82. Okay, so that question here is 68%. Okay, so 68% of the students. Okay, next question, B. How many students does that represent? How many students does that represent? So if 68% of the total, let's go back to the original problem. There's 800 students in the class. So let me put it here so we can see it better. So total number of students is 800. So you kind of need to know that. So how do you calculate this, right? If we know 68% of the students scored between 68 and 82, how do you figure out, how'd you get that, Shannon? And how'd you get that, Tristan? How'd you get that number? Let's talk method here. Make sure everybody knows.
I took 68% of 800, so I just multiplied 0.68 times 800.
Okay, and guess what? Tristan and Mateo agree with you. So well done. Well done. Okay, so 68% is 0.68 as a decimal, 0.68. So you take 0.68 times 800. And let's do that. Everybody verify that. There we go. Let me get my calculator going here. It's a little slow when there we go. You can use Desmos or you can use, the T84. It doesn't matter what you use, or even your phone for that matter. Okay, so 0.68. I'm just verifying the numbers up there. All right, times the total number of students, 800. All right, there we go, 544. So 544 students. Okay, part C. And you guys stop me if you have questions. I'm just going to go through a variety of questions here, just exemplifying, how to use this, what's called the empirical rule. So next one here, let me ask you this. What is the percentage of scores, all right, between, let's say I ask you between 54 and 82. So between 54 and 82. So now your eyes have to focus in on 54 and 82. Go ahead and work on that. And then give me a response when you're ready. Oh, and when you type in your results here, tell me how you're getting it. What numbers are you adding to get the result? That way, if you type that in, so Alyssa, can you show me how you're getting that? Just to make sure that we're all good here. Well, be careful, Alyssa, on that. 50. You're counting on that one right there, Alyssa. You're counting people to the left of 54. You don't want to count the people to the left of 54. So you're going to have to subtract 0.15 from your result right there. So if you do it that way, so be careful. Chris, how are you getting that?
I just added all the.
Which one specifically? From 54 to 82, what percentages?
Oh, I think I should have added 34 twice.
True. Okay. But from 54 to 82, we're talking about, let me highlight it in red. All of this right in through here. So do the calculation again. So I'm looking at your responses. You guys are, okay. So a lot of you guys are saying, well, there's a lot of different answers up there. But you guys are pretty close. Let's check. So let's check. So 2.35%, all right, plus 13.5%. right? And then plus 34, plus 34. You have to add up all the percentages here. Since there's so many numbers, there's so many different answers up here. Everybody double check your answers on your calculator. There's a lot of different responses. Everybody double check, please, because okay, now Chris and Logan agree. Who agrees with that? The 83.85. You guys double checking? Okay. Try to give you guys enough time to double check. Okay, so it looks like you guys are agreeing now. Let me see if I agree. So 2.35 plus 13.5 plus 68, 34 and 34 is 68. Okay, there we go. So 83.85%. So 83.85%. Okay, now a little sub question on that is like, how many students is that? So how many students does that represent? Use that number. How do you use that number to calculate how many students represents 83.85%? When you're ready, go ahead and type it in the chat. Give me your response here. 83.85% are between 54 and 82, but how many people out of 800 does that represent? So should we round these numbers? Grant, why should we round the number?
Because you can't have 0.8 of a person.
That's right. Okay, so 0.08385 times 800 people. I'm just verifying your numbers here. So let me just verify what, well, you can abide by the normal rounding rules, Joseph or Mateo. Let's just do the customary rounding because you know it's 0.8 is beyond 5, so we can round up. But let's just check this out. So 0.08385, all right, times 800. What did I do here? Did I type it in incorrectly here to 0.03?
Is there supposed to be a 0 in front of the 8385?
No, that's my mistake here. I didn't mean to say that. You got to shift the decimal left 2 places here. Thank you. So that was a mistake. So I knew I did something wrong. So 0.8385 times 800. There we go. That makes more sense. So 6, so let's round it. All right. Just round it up. Just abide by normal rounding rules. Okay. Last question on this one here, and then I'm going to put you guys in a breakout group because you guys are doing, it looks like you're doing. So why, Tristan, what were you thinking on that with Mateo? Why do you guys think you would round down?
Well, because like normally when you're talking about people, or at least for like physics, like if you're talking about how many people could fit on a boat before it would sink, like you wouldn't round up because it's like that, like say you got 68.5, you just say the 68 because you can't have 0.5 of a person. But if you rounded up, then that's too many people and then the boat would sink. You know, it's just like, I guess with people or something like that, it would always round down, at least for what I would deal with.
I'll go with that.
Because
I'll go with that. Okay.
Yeah, if you were to say like 671, then that amount of people aren't actually fitting in that percentage. That's too many people.
I'll go with that right now. So let's round down, and I'll think about that a little bit more based on what you said, but that actually sounds pretty logical. So let's go with 670, and everybody will make a little note, round down, and I'll go ahead and do a little research on that just to make sure that that's correct, and I'll respond with you guys later. But let's go with that as our in respect to the rounding rule here, in respect to like actual living things in this case. That's fine. Thank you for your thoughts on that, and I appreciate you guys like challenged me on that. That was good. I like that. Okay, last question before I put you in a group is like, how many students scored, let's say between greater than 96. Let me change it up a little bit. So how many students scored greater than or equal to 96? Last question. So whenever you're ready, go ahead and tell me your thoughts. And when you go to the chat, tell me how you're calculating here too, by the way, so that I know that everybody knows how to calculate it. Mateo, be careful. It's 0.15%. So change the 0.15% to a decimal first before you multiply. Chime in, guys. On in this portion here at the end, in this little purple area in here is 0.15%. Ah, there you go. Okay, now round it, guys. Round it. So that's, based upon what. Very good. Good response, Alyssa, based upon what, based upon the calculations there. So good job, you guys. All right, so 0.15% is 0.0015 as a decimal. So 0.0015 times 800 is approximately 1.2. So we say one student scored greater than 96, because we're going to round down according to our previous discussion too. All right, round down no matter what with respect to people. Awesome. Any questions before we give it a shot in breakouts? Okay. Okay, then let me pose the problem here first, if there are no further questions. So let's write it down. So this is in your groups here. All right, so in group. Okay, so suppose we have test scores from 600 students now. So suppose test scores, okay, we'll just deal with test scores because it's easy to deal with here. So suppose the test scores from 600 students. So there's the total population there. So 600 students is normally distributed all right, with a mean. Let's change the mean to 63. So mu is 63. And standard deviation. It's my dog in the background there. So with standard deviation, sigma equal to 4. Okay, so you have your 2 pieces of data or 3 pieces of data here. You know how many students there are. You know what the mean is, and so on. Okay. Apologize for the barking in the background. Okay, so the first thing I want you to do in your group is to draw the distribution. Okay, and keep space there. So make space for that because you're going to need the graph in all your calculations right there. After you draw the distribution, I want you to answer the following questions here. So what is the percentage of students or scores, actually, scores between 55 and 67? This will be easily figured out once you draw the graph, okay, using the empirical rule. After you do that, you have to answer how many students does that represent? Question mark. Okay, that's that one there. And again, leave space in between these for your calculations. And then next one, what is the percentage? Less than 60% or 67%, less than or equal to less than or equal to 67%. And then you can also answer how many students does that represent? And then the last question here for you guys is what is, or how many students actually, how many students scored, let's say greater than 71? Okay. So I know you guys are writing that down. Any questions before I put you in a group of 3 or 4?
Can you show the question one more time?
Sure. Is that too small on the screen for you? Do you want me to enlarge that for you?
That's good.
Mateo, can you see that okay?
I can see it. That's good. Yeah. Thank you.
Yeah, no worries. So we have 600 students in a normal distribution. The mean is 63, standard deviation is 4. You need to draw the graph first as a bell curve and label it properly. Make sure that you guys agree upon that in your groups. And then you can answer the 3 questions. And then when we come back, we can do a little, we'll just check everybody and make sure everybody's good. And then in the last part of class, I'll let you go. You can spend the last half an hour just solving one homework problem, and then you can submit your work afterwards. Okay? Is everybody ready here? All right, let me see, we have 30, oh my God, we have 35 people. That's a lot of people. Okay, we need 9 breakout rooms. So 9 times 4 is 36. So 9 breakout rooms. And I'll give you guys 10 minutes to work on it. Hopefully that's enough. If not, you guys let me know. Okay, here we go. Let's see, 10 minutes, 1, 2, 3, breakout. Here we go. Okay. I didn't mean to pull you back too early. Would you type in ready in the chat if you actually finish your calculations here? Because I'm not sure if all groups had a chance to finish. And I didn't mean to pull you back if you needed more time. So I apologize if I did. Oh, it looks like a lot of you guys are ready. Okay. All right. I had some fun going into some of the groups. I had some good discussions with you guys. And some of you guys are really discussing well, and some of you guys are kind of quiet in your groups. And I would highly suggest that you guys get vocal. The groups that were very vocal and talking with one another, when I was listening to the conversation, not helping, just listening, it was really good. And it showed that the groups were really on task, and they're helping one another, checking results on with each other, and it was good. So I encourage you guys to do that. Okay, so real quick here. So we've got, let's see if I can we'll get the results here in a minute. I'm just gonna draw the graph real quick. So we got a 63 for the mean. And we'll put in the numbers here so that just that you guys make sure that you are on the right track. So to the right, we're adding 4, so 67, 71, 75. To the left, 59, 54, and 50. There we go. I think that's correct. No, that's not right. 50, what happened here? 55, excuse me. Minus 4, so 55, and then 51. There we go. That's a little bit better. Okay. All right, so let's go to the class. Let's go to the chat, actually. Tell me what you guys got for the percentage of scores between 55 and 67. So let's just make sure, 55 to 67 in here. And if you guys disagree, put in your answers here. If you're not sure, tell me, and then we'll detail it out. But I agree with that there. Okay, so 34%, 34%, and the other one's 13.5%. When you add those up, you get 81.5%. Very good. And then you got to calculate how many students. So will you tell me that? What'd you guys get for the number of students in that range? Okay, and you guys agree upon that too, as well. So let me see, 0.815 times the total. What's the total? 600, okay. And that's about 489 students scored in that range. You guys speak up if you have questions. Okay, next one here, how many that are less than or equal to 67%? So in here, less than or equal to is all in through here. So from 67 to the left, less than 67%. So what's the percentage of that? You guys go ahead and tell me what you got in the chat there. Oh, okay, I just noticed that. So you guys are coming up. So will you guys tell me how you got that number? There's different ways to get it. Would you guys tell me how you achieved 84%? I want to see your thought process here. I agree with that. Just tell me how you're getting it. You can vocalize it or type it in, either one. A couple different ways to get it. I can think of like 2 or 3 different ways to get that number there. So okay. So Kayla just added everything down from 67. Did anybody do it differently? Because she would have to add the 0.15, 2.35, 13.5, and then 34 and 34. That's one way to do it. Okay, you could do it that way, Alyssa, sure. That's the same thing as Kenley's. Okay, that's another method there. That's fine. Okay, so you subtracted the area on the right from 100 to get that. So, and then, oh, look at that. There's another way. That's the easiest way right there. Mateo, I just said 50% is to the left plus that 34. I think that's probably the easiest way to do it. All the other ways are totally valid. So everything that I just saw up there is totally valid. Well done. So I'm just going to make note of this because this probably the fastest, easiest way to do it. 84%. So how many students is that? So what's 84% of 600? Can you guys help me out there? You're doing great, by the way. Nicely done. Okay, so that's quite a few people. So 504 students scored less than 67%. Or excuse me, less than 67, not 67%, but less than 67. That's what I meant to say. Okay, and last one here, how many students, so this is a quantity here, scored greater than 71. So we're talking about in here. So what's the percentage in here? So how many greater than or equal to 71? How many? So what do you guys think on the last one here? There's 2.35% of the students in here, and then 0.15% in here. Not very many students here. So how many students total that scored greater than 71? So Garrett, give me that's the percent. Garrett, that's the percentage, but I asked you how many. So use that percentage, 2.5%, and then it's 2.5% of the 600. Alyssa, you got the number of students less than that. We want greater than, not less than, but greater than. Okay, so there's 2.35 plus 0.15%. These are percentages is equal to 2.5% of the 600. All right, and then if you check that out, so 2.5% of 600. That's 0.025 times 600. And if you check that calculation, I think it's about 15 students. Not very many, because that's the top of the scores. Okay, let's pause here. Any questions so far today? Today was not using the Z-tables like last time. It was just using what's called the empirical rule, or what is commonly known as the 68, 95, 99.7 rule. And if you're feeling pretty strong and confident, type in all good, just so I know that you guys are with me. I want to make sure that you have a chance to ask questions at any time. Fair enough. Then I'm going to give you the rest of the period just to solve your single homework problem. So let's go to Canvas real quick. So let's just follow me on your Canvas. Let's go into period 1 here. Let's go down to section chapter 1 or section 1. Chapter 1, section 4 down at the bottom. And the last one here that I'm highlighting called 1.4 using the empirical rule. Go ahead and click on that. And in this right here, you're going to be submitting your notes and your homework. And your homework is this link here. So go ahead and click on it and just open it up and make sure that I want to make sure that you can open this Google link up here. So I'm hoping that I set it right. I just asked you one question similar to what we just did. And then when you open that up, just give me either a thumbs up on the screen or type in the chat that you were able to do that. Preston was able to get it. I want to make sure that you guys have access. Thank you, Justin, Rebecca, Shannon, thank you. Okay, so it looks like I got the link working. Thank you guys for the response there. Okay. So when you're ready, whenever you solve this homework problem here, take your notes and this all in one file, but put this on top, please. Put your homework on top, put your notes in back, just scan them all as one file and upload that anytime today before midnight and you'll be good to go. Okay? Are we good? Give me a big smile if you're good. That we had a successful day. All right. All right, listen, that's all I've got for you today. That's all I'm going to be doing with you guys today. And so just work on this one homework problem and submit your work and you're all good to go. And then look in for yesterday, or there's going to be something to do over the weekend. So just look out for that when it's ready to get ready for the next section, because we have 4 days until Tuesday, Friday, Saturday, Sunday, Monday. And we'll start the section 5 over the weekend to give you guys plenty of time. And then we'll talk about it on Tuesday, which is a long time from now. So you guys have a super day. Good job today. I'm proud of everybody here. well done. All right. And have a good day. Get some, go up and get some exercise. Ethan, go take a jog or something, as we were talking about, and then do your homework after that, or have breakfast or something. So you guys have a good day. Unless you need to stick around and talk to me personally, I'll see you guys in a few, next week or sometime. Okay. Take care. All right. See you guys. And if you guys need to stick around, if you want to talk to me privately, that's fine too.
Are you able to talk just real quick?
Sure.
Okay.
Always.
Yeah. Okay. So I think my mom emailed you about it, but I think she just like wanted to make sure. I don't think my grades are inputted in, and I'm pretty sure you just said you're like catching up on like, getting everybody's stuff in, but I just like wanted to make sure.
Yes. The assignments. Yes. I graded the quiz and the quiz grades are in.
Okay. Yeah. And then I think I had like, I was marked absent for some reason, and I don't know if that's been cleared yet.
Which day, Ethan?
I believe it was either the 20th or the 24th. Let me just go check real quick. Just give me one moment. I'll be right back.
Yeah, no worries. Matthew, what do you need? Matthew. Yo, buddy.
Okay. I guess it's both the 20th and the 24th. So both days.
All right.
Because I make sure, because I always have my camera on for that like exact reason. Because I'm always like as much as I want to have it off, it's like I already know I could see that as like a obstacle or whatever if that happens.
Mm-hmm.
So
yeah,
as long as it's all taken care of, we'll be fine.
Sounds good, Matthew. Or Ethan. I'm looking at Matthew.
It's okay. It's okay.
No, you're Ethan. I will take a look at that and check that out for you. And like I said, I am getting caught up with the assignment grades. Those are going to be in definitely by Saturday. My goal is, like I said, by the end of the week.
Yeah.
But if you want to show your parents your quiz grade, you can do that because I graded those and I talked about that as well.
All right.
And then we'll have another quiz next week, just to give you guys some chances to, work on it as you go and show your thinking. All right. But I'm proud of you, man. You're doing great. Keep it up.
Thank you. I appreciate it. You have a good one.
Sounds good. See ya.